So my name is Minn, and today I will be presenting about the decentralized identity identifier assisted metaverses. So it is about reference from a paper by the first author, Minn. So I will continue. So when it comes to metaverses, we also think that we only see the famous one like the sandbox or Facebook's metaverse or maybe the decentralized. But the thing is, these things are centralized. It means if something's broken by their company or their services or systems, people are locked out. And the problem is we cannot cross authenticate through metaverses. So that's the problem. So we need a secure and decentralized authentication framework for the metaverses. So currently, we now have the centralized version of metaverses. Those are the most popular ones. We can see Roblox and maybe Fortnite or something. The problem is if something in them fails, everyone locked out. Nobody can access it. And another problem is that they cannot jump from one metaverse to another. So there comes another centralized problem, like we have identity theft, people can steal other people's data, and maybe there are some attacks to one database and all your data are out. So we have those problems. So now we are trying to transition into a more decentralized approach. In a decentralized approach, we will use DID. What a DID is like decentralized identifiers on the blockchain, meaning if someone can want to give their data or share their data, they can do it. But their data is their own. They are not owned by any but other parties. And another is the MEC. MEC is the multi-access edge computing units. So MEC, they are basically server hosting the metaverses. So if you come from the 5G systems, you will know the word MEC. We usually use this to increase the computing power by putting those computing units near to the edge of the network. So another is the blockchain. That's where we will store the DIDs and another smart contracts to regulate these metaverses. So in our systems, we have usually four entities. The thing is the user. The users are the people who are trying to use our metaverses, and we have the set metaverses in the MEC server, and we will have a public blockchain where we will store the contracts and do other smart contracts and storing of DIDs, and trusted authority where we will use to register the users into the set metaverses. So we can see that we have all these entities in our systems. So we will go a little bit. So that's how our systems authentication flow works. So this is written so that you can see in which phase what entities are involved. For example, in the registration phase, the user involved directly with the TA or trusted authority. Then the trusted authority gives the request to the first MEC server, and the set metaverse verify and return the VC is verifying contract. So the thing is now we have registration phase completed. After that, the user can send the authentication request to the metaverses and get their access. But to do the cross metaverse access, the user has to go through the authentication request to the MEC server. The MEC server then forward the request to the sub-metaverse, and the sub-metaverse regenerate the VC back to the user, so the user can use the services from this metaverse. So what is this approach is good for? Because the users only need to do the TA, trusted authority registration phase only once during their registration phase. So after that, they want to cross metaverses, they do not have to go through TA again. Everything is handled by the first registration metaverse next to the other metaverses the user want to jump. So that is the overall flow of this proposed method. So we can see that in that proposed method, we only have the only login function is a cryptographic computing function. It's called bilinear pairing, and it only costs 2.7 milliseconds. That means the computation speed is really, really fast, and we can thank this to the MEC servers. So if we usually use normal transfer protocols and anything, it will be slow, but we can see MEC talking directly to each other. It really increases the performance and the speed of the authentication requests. So another thing is, so that's how we can see it. So from this bar chart, we can see that the only thing that's blocking or the bottlenecking our design is the bilinear pairing. However, we cannot reduce it because it is a cryptographic extension that takes in other inputs and produce one cryptography output. So that is the blocking point and the results. So as the conclusion, we can see that the metaverses have a better confidentiality and integrity because it uses DIDs. So the users can own their own data. So you are not giving your data to anyone without your access. And another thing is the signature enforceability. That means the user, they try to log in using their own blockchain wallets so that they have their own private keys. So if you know your private key and no one else can know your private key, that's how we cannot forge the signatures. Another thing is cross-method authentication, that's I explained before, and privacy preserving, that's also related. And another thing is this one, accountability and non-repudiation. So what is it good is that you use your private key to access those services, do things on the metaverses. That means if you make something bad, everything can be traced back to you. So if you do something and you're gonna say, hey, I never did it, that's not gonna happen in the metaverse. So you are accountable for your actions. That enforces accountability in the metaverse. So that is the strength of this proposed method. So as the outcomes, we can see that the DID assisted authentication scheme has provided a fast and secure decentralized method for cross metaverse applications. And another is the MEC integration, and I've already explained it. The MEC make sure we have the transfer of data in a low security and higher performance, and making authentication seamless because those are like talking directly to each MEC server to MEC server. And yeah, so as the future research, we can focus on increasing and maybe fine-tuning the interoperability mechanism in metaverses. So that is like we have given the base authentication system that people can use. We just for the future researcher, they can try to improve the interoperability. So I think that's it. So that is for my presentation, and thank you very much. Now is the Q&A section.